of center. We're talking about measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. As such, measures of central tendency are also called a central location. They're also called averages. I know I'm going to say average with mean most of the time, but every one of them that we're learning on this first page is an average. If you're reading a statistical chart and it says average, it can be using any one of those three, even though you just think it means the mean. Let's start with the mean. So the mean. Most of the times when you say average, you're thinking mean. The mean is the most popular and well-known measure of central tendency. In order to calculate the mean, all you do is you add up all of your samples or your data items, and then you divide by the number of items you have. I think all of us have seen this, but we probably haven't seen the notation. So when we're talking about sample mean, I use something called X bar to stand for your mean. Anytime you see X bar, it automatically means mean. Well, the equation for this can be written like this. Like, my tip came off. All right, it's going to be written as X bar equals your first data set, which we'll put X sub 1, plus your second data set, plus your third data set, so on and so forth until you get to your last data set. We'll do X sub n. Then we divide everything by n. Make sure you have some of this down unless you actually know the equation for X bar. Your goal is not to speed through this. There's lots of notation that you have to know. All right, the other way we could write this is X bar equals, and it's something called a Riemann sum. It's a big sigma with an X after it, divided by n. That just means sum. Add all of your X values together and divide by how many X values you have. It is called a Riemann sum. But both are equations that we use, and they both mean the exact same thing. Add up your data and divide by how many you have. All right, so it says find the mean of the following data set. So we're going to go X bar equals. How many data points are there? If you haven't already, count them all up and tell me how many data points we actually have, or data items. Are you? 15. We have 15 of them. So what we're going to do is we're going to start with n equals 15. Anytime you see n in statistics, I shouldn't say every time, but most of the time when you see n in statistics, that stands for the number of data items. I won't tell you this in the future. You just have to know if I say n equals something, you have to know that stands for your number of data items. So one more time, n stands for your number of data items. So we're going to have X bar equals whatever that sum is divided by 15. So now when I take out my calculator, I go 3 plus 7 plus 5 plus 13 plus 20, blah, 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 all the way till I get to 29. What happens when I add all of those up? What sum do I get? Yes, Sam? 330. And what's 330 divided by 15? Yeah. It's going to be 22. Your average is going to be 22, or your mean is 22. The next thing we're going to talk about is median. The odd thing is, most of us know what the mean is. We always think when I say average, you think mean. The weird thing is, most of the time in statistics, we usually look at the median. When I look at your grades, I look at your median. I don't really care much for the mean. I always look at the median. And we'll talk about why on the back side. But just so we know, keep aware that median is used the most, and we'll talk about why on the other side. All right, but first, what is the median? The median is the middle score for a set of data that has been arranged in order of magnitude. Magnitude just means size. So whenever I ask for the median, the first thing you have to do is organize your data from smallest to largest. So if I'm given 3, 9, 11, 8, and 4, I'm going to organize it from smallest to largest. So that would be 3, 4, 8, 9, and 11. Which number is smack dab in the middle of all the data? Which number is smack dab in the middle of all our data? 8. So what I usually do is I just put a little line at 8 and say that's my median. Your median equals 8. And why do I draw that line? Because now I can actually visualize, okay, there's 2 to the left of it, there's 2 to the right of it, that's smack dab in the middle of the data. Now, this is going to seem pretty stupid because we only have 4 data. It's pretty easy to see which is in the middle. But there are times where you have so much data that you don't want to have to count going in until you get to the middle. There's a way to know exactly where the middle of your data is, and that's called your central point. Your central point. Just want to see if I named it anything else. Central point or central position. That was the other word I was looking for. So central point or central position, however you want to. I'm just going to call it our central point. You're always going to know where the middle of your data is if you just take your n, add 1, and divide by 2. That's going to tell you exactly where the middle of your data is. So that is something you should know. For this one, we have 5 data items. So it would be 5 plus 1 divided by 2, which would be 9 divided by 2, which would equal 4. Ooh, what am I doing? It would equal 3. I was on the next problem in my head. So that means if I count for 3 from either side, that's going to be the middle of my number. So I go 1, 2, 3, draw a line. That's my median. It can also speed things up even if you only have like 10 items. All right, it's easy to be able to just count out and put your line there. All right, our next one, we have 4, 45, 22, 11, 3, 14, 13, and 11. I need to find the median, so that means I need to organize it from smallest to largest. So we have 3, 4, looks like 11 is our next biggest. 11. Then we had 13, 14, looks like we have 22, and then 45. I'm going to find my central point. This is something you can just do in your head. We have 1, 2, 3, 4, 5, 6, 7, 8 things. So our n equals 8. So our central point would be 8 plus 1 divided by 2. This one equals 4.5. That means I'm going to count 4.5 from the left. So we go 1, 2, 3, 4. 0.5 would be between 11 and 13. So my median would be smack dab in the middle of 11 and 13. What number is smack dab in the middle of 11 and 13? Yeah, 12. If you're not sure if it's weird decimal, you're just going to say, okay, my median's between 2 numbers. So your median will be the 2 numbers added divided by 2, which would just equal 12. Obviously, 12 is probably an easier way to go about it. But there are times where it's weird, where it's like 11 and 17, and you're not quite sure. Just do 11 plus 17 divided by 2, and it'll give you your median. Now with that line drawn, I will double check. Okay, I have 4 on the left-hand side of the line. I have 4 on the right-hand side. That is, in fact, my median. All right, that is our median. Our median cuts our data down the middle. There's 50% on the left-hand side. There's 50% on the right-hand side. The next thing we're going to talk about are quartiles. Quartiles are basically medians of medians. So where your median cuts your data in half, your quartiles are actually going to divide it into quarters. That's why they're called quartiles. So they'll divide it into quarters. So now we have 25% of our data is here, 25% is here, 25% is here, 25% is here. We're just doing it into quarters. Like I said, quartile 1 is the median of the median. Quartile 3 is the median of our upper median. So to do this, we're going to do the exact same thing we do when I was looking for a median, and I'd first put everything in order of magnitude. So we're going to have 3, 4, looks like we have 7, 8, 14, 15, and 19. What would our median be? What would our median be for this one? Yeah.
8.
It'd be 8. We have 1, 2, 3, 4, 5, 6, 7, 8 things. 8 plus 1 is 9. 9 divided by 2 is 4.5. So we'd go 1, 2, 3, 4.5. It'd be halfway between 8 and 8, which is still 8. So this would be my quartile 2 would equal 8. Our quartile 2 is just our median. Most of the time, we just call quartile 2 our median. Our lower quartile, which is also called quartile 1, is going to be the median of these 4 data. So we have 3, 4, 7, 8. Quartile 1 is going to be smack dab in the middle of that data, so it'd be between 4 and 7. So that would be my quartile 1. Quartile 1 equals halfway between 4 and 7, so we can just do 4 plus 7 divided by 2. That would be 11 divided by 2, which would be 5.5. That's my quartile 1. That's my quartile 2. Quartile 3 is going to be smack dab in the middle of those upper 4 data points. So our quartile 4 is going to be right here. Quartile 3, I should say. Our quartile 3 is between 14 and 15, so that's going to be 14.5. Once again, lower quartile is also called quartile 1. Quartile 2 is oftentimes called our median and more often than not called our median. Quartile 3 is sometimes called our upper quartile. We have 3 quartile numbers. All right, the last thing we're going to talk about is mode. Mode is the most frequent score in our data set. That is that number that appears the most in a particular data set. So we look at that first example. It says 7, 13, 18, 24, 9, 3, and 18. Which of those numbers repeats the most in that set? Sam? 18. It's in fact the only one that repeats because we have an 18 here. We have an 18 here. 7 doesn't repeat. 13 doesn't repeat. 24 doesn't repeat. 9 doesn't repeat. And 3 doesn't repeat. So our mode is going to be 18. Our next set is 24, 15, 18, 20, 18, 22, 24, 26, 18, 26, and 24. Which of those numbers repeat the most? Yeah. 24 does. Aryan? 18. Which one repeats more, 18 or 24? Oh, it does the same. Well, guess what? Your mode can have 2 answers. For this one, our mode is going to be 18 and 24, because if we look at 18, 18 appears once, twice, 3 times. Our 24 appears once, twice, 3 times. So our mode is going to be both 18 and 24. This is oftentimes called bimodal. Or if it happens more than twice, it'll be multimodal. It is multiple modes. Know those words. Our last one is 2.7, 8.3, 3.5, 5.1, 4.9. Which of those numbers repeats the most? Yeah. None of them. So we have no mode. Make sure you guys are taking notes. I can see on several of you don't have bimodal or multimodal even written down. What's going to happen on the test if I say is this bimodal and you never studied it? Make sure you write down those notes. Yeah?
So you can have as many modes unless it's like the number.
Unless it's all of them. You can't have everything as your mode. All right, it's useless then. So you could have all of them except for one could technically be your mode. Most often it's either 2 or 3. most often. But as long as it's not all of them. All of them means there's no mode. There's none that appears more than all the other ones. All right, that is our central tendencies. Now what we're going to do is we're going to talk about outliers and averages. All right, so an outlier. The definition of an outlier is a value that lies outside. In other words, is much smaller or larger than most of the other values in our data set. So it says that Alex is a star player of her basketball team. She scored 20, 17, 19, 15, 0, 1, 19, 17, 14, 21, 18. Can you do me a favor and cross out one of those 19s? One of those is a typo. That gives it too many games. All right. Points in the last of the team's last 10 games. What is the mean and median of the score? So let's first look at those numbers. Which two numbers really stand out to you as being different than all of the other ones? Yeah.
0.
And maybe the 1?
20. Wait, what? Oh, 1.
Yeah, 0 and 1. Those seem different than all the rest of them, right? I mean, she scored 20, 17, 19, 15, 0, 1, 17, 14, 21, 18. Don't those seem like anomalies? Maybe she was hurt. Maybe something happened in those two games. But don't those just stand out to you as being different than the rest? Well, we're going to determine if those are actually statistically considered outliers, being that they're so far away from the central we barely even count those. All right, but we're going to start off with first calculating the mean and the median of the scores. In fact, I want you to calculate the median and the mean of these scores. And I want you to look at and ask yourself, which would be the most accurate representation of her kind of average? So we're going to calculate our mean and we're going to calculate our mode. So once again, your median is less affected by extreme values. So in this case, 17 being your median would be the most accurate representation of these to show that 0 and 1 didn't quite affect. In fact, this is so important. I'm actually going to write it next to the median one. I'm going to put a big thing on it that says not affected as much by extreme values. So mean, anytime you have an extreme value will either get pulled up or down with those extreme values. Median will slightly get pulled up or slightly get pulled down, but not as much. That's why whenever you look at my grades, I will always do a median, and I don't really care about the mean. Like when you ask how did everyone do, I always say the median was about a 93% or something like that. That way if someone bombed it and got a 20% on it, I'm saying, well, I get that he bombed it, but it shouldn't be pulling down the whole class average. It's just one kind of score. All right, let's get into this. So we know that 0 and 1 seem weird. They seem out of place. But in statistics, you actually have to be able to say, I know for a fact this is an outlier. 0 and 1 definitely look at it. But what if it was 10? 10 seems lower, but is it that far away from it that I'm going to call it an outlier? So outliers have a very specific calculation. And that is, in order to be an outlier, it has to be data that falls outside 1.5 times your IQR away from the nearest quartile. So first let's talk about IQR. That is called your interquartile range. That is just Q3 minus Q1. I'm sorry. It should be Q1. Q3 minus Q1. So it's our top quartile minus our small quartile. That'll be your interquartile range. What is the value between those two? And then real quick, I want to put a little note here. We're going to come up with two boundaries. I want to know if these numbers are too low to fit in my data set or are these numbers too high. So to come up with those two boundaries, we are going to do quartile 1 minus 1.5 times your IQR. Anything lower than that will be an outlier. And our top value is going to be quartile 3 plus 1.5 times our IQR. That's going to create our upper boundary for whether it'd be an outlier. So if we have any numbers less than this value, it'd be an outlier. If we have any numbers bigger than this, that would be an outlier as well. Yes?
So it can't fall between Q3 and Q1 for it to be an outlier.
Correct. Oh, definitely not. It definitely has to be outside our quartiles to be, because that's our primary data.
Okay.
50% of your data is between quartile 1 and quartile 3,
Okay.
because your median is right there.
Okay. So does that say Q3 minus Q1 or Q3 to Q1?
This says Q1 minus 1.5 IQR.
No, for the interquartile.
That's Q3 minus Q1. That's just a number we need for this calculation. You'll see. We're going to do the whole thing. All right, so obviously we're dealing with quartiles, so let's first come up with all our quartiles. So what I did is I actually wrote all the data out. I wrote my 0, 1, 14, 15, 17, 17, 18, 19, 20, and 21. Now we have 10 data points. Well, 10 plus 1 divided by 2 is going to be 5.5. So I just have to go 1, 2, 3, 4, 5. 0.5 is going to be my median. So our median is right here. Once again, I kind of do this every single time. I do my n plus 1 divided by 2. I think it makes it a little easier. So that is my quartile 2, or my median, is 17. My quartile 1 is going to be smack dab between 0, 1, 14, 15, 17. That's 5 pieces of data. 5 plus 1 divided by 2 is going to be 3. 1, 2, 3. This is going to be my quartile 1. And then my quartile 3 will be that 19. All right, so what I'm going to do here is I'm going to call, it's something called the 5-number summary. Your 5-number summary is going to have your minimum, which in this case is 0, our quartile 1, which is 14, our quartile 2, which is 17, our quartile 3, which is 19, and our maximum, which in this case is going to be our 21. This is known as your 5-number summary. Whenever you're dealing with quartiles and stuff, you're always going to come up with those 5 numbers. All right. It says that I need to have an IQR in order to even start talking about my outliers. So let's first do our IQR. So our IQR in this case is going to equal quartile 3 minus quartile 1, which would be 19, minus my quartile 1, which is 14. So my interquartile range is going to be 5. All right, now let's talk about our outliers. Let's talk about our outliers. Either our outliers are going to be too big of numbers to fit in our data set, or they're going to be too small, that they're just these really weird numbers that I don't want to focus a bunch of attention on. So we can either have too big or too small. Let's start with our too big. Let's call that our upper limit. Your upper limit is going to be that one that's Q3 plus 1.5 times your IQR. Well, we know what quartile 3 is. It's 19. Plus 1.5, my interquartile range is that 5. So we're going to have that 19 plus, make sure I didn't make any mistakes, yep. We're going to have the 19 plus 1.5 times 5 is going to equal 26.5. Do we have any scores that are bigger than 26.5? So do we have any outliers that are too big? No. So there's no outliers to that side because there's no points greater than 25. So in other words, we have no scores above 26.5. So we're good there. All right, let's do our lower limit. Our lower limit's going to be quartile 1 minus 1.5 times our IQR. Well, our quartile 1 in this case was 14, so we're going to do 14 minus 1.5. Our IQR is still 5. So we have 14 minus 1.5 times 5, which is going to equal 6.5. Do we have any values that are less than 6.5 on our data? Tori, what are we looking at? 0 and 1. So that means 0 and 1 are both outliers. So because of this, our scores 0 and 1 are outliers. So the beginning question is, determine if 0 is an outlier for Alex's score. Was 0 an outlier for Alex's score? Yeah. It takes a lot of work for one little question, but now we can say, yep, 0. 0 is an outlier. So is 1, but they didn't ask about that. They said, is 0 an outlier? So in stats, we're not going to get too much into it. When you have outliers, you treat them a bit differently. Sometimes you can exclude it from your data, and other times you just point it out to say, hey, my average turned out a little high, but I had 2 outliers. That's why the average was high. I think if I redid this study, I wouldn't have those outliers, and it would be a lower value. All right, the last thing we're going to talk about is something called a box plot. It's also called a box and whisker plot because we have a box. There's little whiskers that go off of it. Well, that box plot right there is actually that same 5-number summary that I wrote here. We need a minimum, quartile 1, quartile 2, quartile 3, and a maximum. Well, if you look at a box and whisker plot, your minimum is where your graph starts. Quartile 1 is actually the start of your box. Quartile 2 is going to be the line inside your box. Quartile 3 will be the end of your box. And finally, the end will be your highest value. Who wants to take a guess at what that asterisk would be? Hint, we just talked about them. If you look up like a centimeter. Yeah, the outlier. That would be an outlier. All right, there's important stuff on here that we need to point out. This is our median. Your median will not be smack dab in the middle of your graph. There's nothing wrong with it being off to the left. There is no mistake on here. These whiskers will not always be the same length. These will not always be the same length. You might have a really crushed box. You might have a really long box. It just depends on your data. So don't graph it and go, oh, this isn't perfectly in the center. It's not a perfectly drawn one. It's going to happen where it's very condensed, or it might be really long, and you might have weird things happening inside. And where that stems from is what's happening here. This is your median of your data. 50% of your data is to the left, and 50% of your data is to your right. Another important thing. If this is 50%, and this quartile 1 breaks it up into quarters, well, 25% of your data is on that line. So 25% of your data is right here. 25% of your data is inside that left part of the box. 25% of your data is in the right portion of that box. And finally, 25% of your data is on that last line. So if this was some survey where I counted all the pencils that were in your backpack, and I said how many of the students had more than 4 pencils in their backpack, you'd look at 4 and go, okay, 25 plus 25 plus, oh, there's 75% of students would have more than 4 pencils in their backpack. That is how every box plot is. It always breaks it into a quarter, 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 always. No matter how weird it looks, even if this line was this itty-bitty line, it'd still be 25% of your data. You know, if this box was tiny, that'd be 25% of your data, and this one's big, that's still 25% of your data. Each line cuts off 25% of your data. All right, let's go ahead and make a box plot. Yes?
Does the length of the line determine how many numbers fit into that?
Nope. It's still 25%.
Then what does the line tell us?
The line tells us 25% of the data is between 2 and 4.
Okay.
It doesn't tell me how many data points are in here. It could be 100, it could be 4. It just means if there was 4, there'd be 4 datas in here, 4 in here, 4 in here, and 4 in here. All right, all that spread really tells you is variation. How far apart are the numbers? So if all your data is really close, so if we look at this example, all these numbers are pretty close. So that graph would be kind of smushed.
Yeah.
All right, the more variability you have, the longer those lines and the longer the boxes are. Okay? All right, let's go ahead and make this graph because then maybe it'll make a little more sense. So we're supposed to construct a box plot from the data, 25, 30, 35, 28, 20, 37, all of those numbers. So the first thing we need to do is we need to come up with a 5-number summary because that's, in fact, what a box plot is, a 5-number summary. So the first thing we're going to do is we're going to list them in order. So let's go ahead and go 25, 28. Our next one would be 29, 29, 30, 34, 35, 35, 37, and 38. All right, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So this is my quartile 3 is 35. All right, so our minimum value is 25. Quartile 1 is 29. Quartile 2 is 32. Quartile 3 is 35. Our maximum is 38. Our IQR, not usually asked, but what's my IQR in this one? So we have 6 because that would be quartile 3 minus quartile 1. All right, this is all you need to come up with a box plot. Now, here's the thing. My minimum value is 25. Would it make sense that if I started this line at 1, wouldn't it be really hard to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 25? I would have that much of the graph in this corner. So we're not going to start at 1. We're going to actually start at, usually we start either at the minimum or just slightly before the minimum. Let's in fact start at the minimum. So let's just do a straight line. Possibly not. All right, let's just do a straight line down here. Boom. I'm going to get rid of that. There, that's better. All right, I got a straight line right here. I'm going to go ahead and start at 25. So I'm going to put 25 right there. Why won't it switch over to my thing? There we go. Then I'm going to count up to 30. So we'll go 25, 26, 27, 28, 29, 30. 31, 32, 33, 34, 35, 36, 37, 38, 39. Just go off a little bit. 40. Do we have any numbers bigger than 40? Nope. So we're going to stop at 40. All right, let's do our box first. Your box is going to be quartile 1, quartile 2, and quartile 3. So we're going to start at 29. So I'll look at 29. What I'm going to do is I'm going to draw kind of the left-hand portion of my box. So let's just draw like that at 29. 32 is my quartile 2, so we're going to do the same thing at 32. Then finally, 35 would be my quartile 3, so that would be about there. That is my box. That is my quartile 1, my median or quartile 2, and this would be my quartile 3. Now let's do our whiskers. Our whiskers start at 25. So we're going to draw a line out of our box until it gets to 25. A lot of times people put a little tick mark. There isn't one there, but most of the time we just show it ends here. So right there has to be my minimum. Now let's go up to our maximum. Our maximum is 38, so we're going to draw a straight line until I get to 38, and that would be my max. That would be your first box plot in stats that you have drawn. It's a very important chart. Everyone look up at me really quick. The biggest deficiency high school students have is reading a box plot. Tomorrow we'll talk about stem and leaf. These are big things that show up on major exams. It's important for you to understand how much important data you're getting here. You get your median out of it. You get your mins and maxes, but you need to know how to read it. If you know how to read it, it's super easy. If you don't, it becomes a very complicated chart or graph. Also, remember, 25% of your data is here, 25 is here, 25 is here, and 25% is here. No matter how big or small those lines are, it is 25% of your data. All right, questions for me?